we are going to express the power of a lens. Power of concave lens, power of convex lens. Okay, what is actually power? Power of a lens means the degree of convergence if it is for convex, or degree of divergence. Now what is convergence and divergence? Suppose we consider a convex lens. Okay, this is the principal axis, this is the optical axis. Okay, this is the optical center. Okay, if you pass a ray of light parallel to the principal axis, okay, then this ray, after striking the optical axis, passes through focus. Okay, this focus is real focus. If you measure the length of this focal length from here to here, this focal length is positive, right? Why? Because all the distances measured in the direction of incident ray is considered positive. So this is the power of the lens, the extent of convergence it produces. Convergence, why? Because convex lens is a converging lens. So you can see that the ray of light, incident ray, after striking the optical axis, passes through the focus. So the amount of convergence produced is the power of this lens. Now mathematically, the power of a lens is the reciprocal of focal length. Okay, clear? Why reciprocal? You know, because lesser the focal length, more is the power of convergence. So the power of the lens is inversely proportional to the focal length. So symbolically we can say P equals to 1 by F, and this F has to be in meters. Okay, so that the power of the lens will be in diopters, DIOPTER. This is the unit of the power of a lens. Okay, the power of lens is said to be 1 diopter if the focal length of the lens is 1 meter. So this is about the calculation of power. What about the sign? The power of convex lens is positive. You know why? Because the focal length is positive. Here, this focal length is positive. So the power of a convex lens is positive. Okay. Now next consider the concave lens. Concave lens, the lens which is called divergent lens. Okay. This is the optical axis, this is the principal axis, this is the optical center. If you consider a ray of light passing parallel to the principal axis, okay, the ray appears to diverge from the focus. This is the focus which is virtual for a concave lens. So the ray of light appears to diverge from here. This is the divergent property. So the ray was supposed to pass like this, but it diverges in this way. So this is the degree of divergence. That is the power of concave lens. So again we have the expression power of concave lens. This is negative because when you use the expression P equal to 1 by F, because focal length is negative, okay, why negative? Because you measure the distance of focal length from here to here, and because the length is measured from optical center to focus opposite to direction of incident ray, so this focal length is negative therefore. And because the focal length is negative, okay, so the power of a concave lens is always negative. Okay, so what is power? Power is the degree of divergence or convergence produced by a lens. Clear? The calculation of the power helps us to know the focal length of our obstacles. Thereby we can calculate the power. Okay, for correction of the short side, long side, we use spectacles, which make use of concave lens for correction of short side, convex for the correction of long sightedness. Okay, now this is the expression for power of a lens. Please keep in mind the focal length has to be in meters if you want to calculate the power in diopters. Okay, it is negative for convex, concave, and positive for convex. Now let's consider power of the combination. Power of combination means if you consider the lens being combination of convex and concave like this. Then the degree of convergence of this, degree of divergence of this depends upon the algebraic sum. That means for this, if the power is positive, okay, and for this the power is negative, then the power of combination for the whole, okay, if you consider this as P1, this as P2, then the power of combination P is equal to the difference of P1 and P2, okay. Suppose the power of the convex lens, is plus 3 diopters and the power of concave lens is, suppose this is minus 2 diopters, okay, then the power of the combination will be 3D minus 2D, okay, so this comes to 1D, okay. So this is the power of combination. Now if you want to calculate the focal length of the combination, you can use this formula, focal length of the combination equals to 1 by this power, okay, and that is 1 meter, clear, because the power is 1 diopter, so the focal length is 1 meter, which is equivalent to 100 centimeter, okay. Now next come to the nature of the combination. After solving the calculations, if the power comes positive, okay, then the nature of the combination is convex, and if the power, algebraic sum of this comes to be negative, suppose it is minus 2D, then the power of the combination will be concave, okay. So this is how you decide, clear. So remember, please convert the focal length in meters if you want to calculate the power in diopters, okay, and if the power is given, you calculate the focal length first in meters. If it is coming in decimal like 0.5 meter, 0.2 meter, you can multiply by 100 to convert into centimeters. I hope it's clear to you, okay. Thanks for watching.